Hello and welcome back to another past paper. This time it's for O-level, Cambridge O-level, and we're in May, June 2024, and this is paper 1, okay, version 1, paper 1, syllabus 2210. This is an hour and 45 minutes, okay. Total marks for this paper 75 is, the most important bit that not many students like is calculators must not be used in this paper, okay. So let's have a little look at this. A student has a portable tablet computer. Okay, so a student has a portable tablet computer, okay, like an iPad. Identify two input devices that could be built into the portable tablet computer. Okay, well, if it's a tablet computer, it's generally one of these with a screen, so it's going to have a touch screen. Talking just a basic tablet, yeah, touch screen. And the second one, which is going to be maybe an inbuilt keyboard, but that's going to be sort of touch screen. But it might have something like a webcam. Remember, we're talking input, like webcam. And we can have on the newer ones, we've got biometric. Eye or finger scanner. Okay, so some of those. Identify one output device that could be built into the portable tablet computer. One output device. One output is the only thing I can think of. I'm sure there's more on the mark scheme, but the only thing I can think of for something like this would be speakers. I mean, it's obviously not a printer or anything like that built into it. So yeah, speakers. Yeah. Identify one type of storage device that could be built into the portable tablet computer. Secondary storage. Storage. And I'm going to put SSD. Now it could have a little micro SD card or something like that, but I think secondary storage, SSD, my choice there. Okay, can I move this around? Hypertext markup language, HTML, color codes can be represented as hexadecimal. Yes, they can. Tick one box to show which statement about the hexadecimal number system is incorrect, is not true. It uses the values 0 to 9 and A to F, well, that's correct. It can be used as a shorter representation of binary, well, that's correct. Okay. It is a base 10 number system. Well, no, it's not, it's base 16. So we're going to tick a box, that one, just to make sure. It can be used to represent error messages, it can. Generally in machinery, you might get an hexadecimal code appear, which refers to an error. Okay, and then we've got denary numbers can be converted to hexadecimal. Convert the three denary numbers to hexadecimal. 20, 32, 165. Converting these to hexadecimal. How would we do that? What's the best way of doing that? Well, we know, I'm going to give you a little clue. Because it's base 16, the hexadecimal number will be smaller than the denary number. It'll be a smaller value. So what I'm going to do is I'm going to put here a 1 and a 16. Okay, because the next one up, if I multiply this by 16, the next number up, multiplied by 16, is 2, 5, 6. So none of these are going to be 3-digit binary. They're all going to be 2-digit binary. So we've got to work out how many 16s go into each of these, and then we have a remainder. So, for example, 20, yeah, is, I'm just going to change the colour of the pen. 20 would be one lot of 16 and 4 left over. Okay, so 1 times 16, yeah, plus 4 times 1. Okay, so that's how we'd do that. So it would be, the answer for that one would be 14. Okay, 32. So if you allow me, just rub this out. Okay, nice and steady. Again, 32, we've got 2 lots of 16. Yeah, 0 units left over. 2 16s equals 32, so it would be 20. Okay, 2 0 in hexadecimal. Now 165's a little bit more difficult, but if I break 165 down, 165, that equals 10 times 16, yeah, equals 160. And how many is left over? So it would be 5 times 1 equals 5. So that would give me 165. So 10, if I rub this out, yeah, we know that 10 representing, I think there was a question further up. Yeah, here we go. 0 to 9 and A to F. So these numbers remain the same as denary. From A to F, A equals 10, B 11, C 12, yeah, D 13, all the way to F equaling 15. So we can say that we've got 10 lots of 16, so that would be 10, which equals A, and then we've got 5 left over. So the answer there would be A5. Swap A5. Okay, so that's how we do that one. Switch back to red rather than rainbow pen. Microsoft whiteboard. Question 3. The binary number 10100, zoom in a bit so you can see it. The binary number 1010011 is stored in a random access memory in RAM. Okay, the logical shift of 3 places is performed on the binary number. Okay, give the 8-bit binary number that is stored after the shift has been taken place. So we've got no working space here, but I'm going to go across the top here. 1 1 0 0 0, yeah, 1 0 1. Now we're going to the left. Okay, logical shift 3 spaces is performed. The left shift. So if we're going left and we're that way. Okay, let's go that way. So I'm going to go 1 2 3. Okay, so bearing that in mind, I've got 1 1 0 0 0 0 0 0. So my answer, moving these this way, would be 1 2 3 zeros there, 1 1, and then we fill back in from this end with zeros. Okay, so that would be my new number. Tick one box to show which statement about a logical shift, left shift of 2 places is correct. If we're going, let me try with a simpler number. So for example, if I've got this number, if I go do my 1 2 4 8 16 32, well, let's go to 64. Okay, now if I've got 0 0 0 0 0 0, okay, and I'm going to the left, I'm going this way, a shift of 2, which basically means if I take this 1 and go 1 2, I then get the number 0 1 0 0 0 0 0. So with that in mind, I've gone from 8, yeah, to 32. So I've times 2 and times 2 again. Okay, 8 times 2 is 16, times 2 again would be 32. So I would multiply the number, yeah, by 4. 8 times 4 is 32. So let me take that box there, which is D. Okay? 101 000 11 can be stored as a 2's complement integer. Convert the 2's complement integer to denary. Show all you're working out. Most of the time we're converting a negative denary number into binary, but this one looks a bit differently. So if I put this in this way, if I start with this as my flag, my minus 128, because it's 8-bit, so I'm going to go 1 2 8 64, but this is a minus, 64 32 16 8 4, 2, 1. Okay, so if I go, I've got what? I start with 1 there. So I'm starting on minus 128. I've got no 64s, 132, 0, 0, 0, 0, 0, yeah, 1, 1. So I've got 3 at the end there, and I've got 32. So what I'm going to do, I'm just going to move this up a little bit so you can see. What I'm going to do is I'm going to start with 128, yeah, minus 128, and I'm going to add 32 to it, okay, which gives me minus 96. I'm then going to add these 3 onto it, so plus 3 equals minus 93. Okay, that is the way I would do it. Now, moving on to D, a binary number is measured as a byte because it has 8 bits. State how many bytes there are in a kibibyte. Kibibytes, if it's kilobytes, you times it by 1,000. But with this, we times it by 1,024. So it would be 1024. Okay, so that's nice and easy. We've done these some of the easy ones. Quite a few marks there. Right. Describe data packets are transmitted across a network from one computer to another via nodes. Okay. Describe the structure of a data packet. Well, what I'm going to do is I'm going to draw one, like a crisp packet. Okay. So here is my packet. Okay. There it is. Now it's split here and here into 3 parts. The first part is the header. And then we've got the footer, a little bit like a page in a word processing document. Header, footer, yeah. And then we've got what they call the data, which is known as the payload. Okay, so describe the structure. Okay, well, I think the header sometimes has IP address of sender and receiver. This has got the data, and that might contain packet number, and maybe some kind of error checking. I think we can get away with just those 3 words. So that is my packet. Okay, packet switching. Let's come back up here. Oh, hello. Okay, packet switching is used to transmit the data packets across the network. Identify the device that controls which path is taken by each data packet. Okay, identify the device that controls which path is taken by each data packet. That's going to be a node. Okay, a node, or that's going to be a node, or to give it this sort of name that you might be familiar with, a router. Okay, but I am going to put in brackets because I know if you've done the IGC or if you've done another syllabus, you might see that it is down as a node. Okay, and for 3 marks, serial data transmission is used to transmit the data packets across the network. Explain why serial data transmission is used to transmit the data packets. Well, generally speaking, the data is split into packets, and the network is long distances. So we use serial because serial works best over long distances. So I'm going to put, first of all, works best over long distance. Okay, now we can read my writing. Okay, so that'll do for 1, but remember it's having 3 marks. So works best over long distances, which means serial will be more reliable and less likely to become skewed. Good word. Okay, skewed. So more reliable, works best over long distances. Yeah. less likely to become skewed. I think that will get us our 3 marks. Okay, question 5. A computer uses both RAM, random access memory, RAM, and secondary storage. State the purpose of secondary storage. Secondary storage is something like the SSD. And basically what it does, it stores data permanently. Okay? If you close your computer down and then you open it again, the data will still be there. It's what's known as non-volatile. Okay? So, one type of secondary storage is optical. Well, it was back in the day. Circle 3 examples of optical storage. Oh my word. Optical, basically, if you consider optical to be sort of the things that are around CDs, yeah, that's sort of optical storage. So a compact disc, yes. A DVD, yes. And then a Blu-ray disc is what they use them. Well, they used to use them on PlayStation 3, maybe on PlayStation 4, not sure. Explain why computers need RAM memory. RAM, faster than secondary storage, used 3 marks with fetch, decode, execute, cycle. Okay. Stores data, information. So the information in temporary memory and volatile. I think that will do. Okay. Right, the computer processor instruction uses a fetch, decode, execute cycle. We just mentioned that. Draw an annotated diagram to show the process of the fetch stage of the FDE. Okay, well we've got, if I do that, with my CPU, and then here we've got RAM. Okay, the RAM is split up into addresses, yeah, and data. Okay, the CPU has the CU, it has the MAR, it has the MDR, and it has the ALU, and the PC, and it has the, which is sort of linked to the current instruction register. Okay, so it's sort of like that. What generally happens is the address is sent, yeah, go and find the address location of where the data, of what data they want. So the memory address register sends a request to the memory address to find the data. Then from the data, then from RAM that goes back into the memory data register. So request for address of data. Okay, data fetched to CPU. Okay, the instruction, the data is sent to the MDR. Then the control unit decides, sorts out what to be done, decode. Okay, so the CU is doing the decoding. Okay, once we've decoded it, we send it to the ALU to be, if there's any kind of logic or arithmetic processing to be done. Okay, So MAR requests the address of the data. The data is then fetched to the CPU. The CU decides what we're going to do in terms of decoding the actual request, the actual information. Okay? And then it's executed to an output device maybe, okay, or sent back to RAM to be restored back into secondary memory. So hopefully that makes sense. Okay, where are we? Question 6. Okay, a computer needs firmware, okay, and system software to operate. State the purpose of firmware. Well, firmware is generally like BIOS. It's stores startup instructions for the hardware. Okay, for the PC. Give one example of firmware. Firmware, based on what I'm writing here, firmware could be BIOS. Okay. Give 2 examples of system software. System software, well, that would be the operating system. Now, don't make the mistake of putting down something like Apple iOS and then Windows, Microsoft Windows. It's going to be an operating system as general, but then any kind of system utility software. So I would put system software as being utility. Utility / setup software. Okay. Well, question 7. Data is encrypted to keep it safe during transmission. Complete the paragraph about asymmetric encryption. Okay, asymmetric basically means it's got 2 keys. Okay, one to encrypt, a private key and a public key. One to encrypt and one to decrypt. Okay, so you might see things like private key, public key. We might see asymmetric in there for encrypting, asymmetric in there for decrypting and encrypting. Okay, so let's have a little look. So something is encrypted. Something is encrypted. I would generally say plain text. Plain text is encrypted into ciphertext. Okay, so they're the 2 we need. Sorry, the plain text. Yeah. Now I'm guessing we might need some of these using a public key. Public key. Okay, public key. Yeah. The encrypted data is then transmitted from the sender to the receiver. The encrypted data is then transmitted from the sender to the receiver. The encrypted data is then decrypted using a private key. Okay? A private key. Yeah, so we didn't need decrypted or encrypted because that's part of the text. But basically, we're turning plain text into ciphertext using a public key. But then when we come to decrypt the message, the receiver decrypts the message using a private key, using their own personal key. Okay, that's how that works. 4 marks. So easy. So let's have a little bit of question 8. A farmer uses an automated robot to plant seeds in a field. State what is meant by the robot being automated. Well, automated basically means, state what is meant by the robot being automated. It means it operates on its own. Operates on its own, yeah, without. I'm going to put human intervention. Okay, operates on its own without human intervention. So let's give 3, based on that, give 3 characteristics of a robot. Okay, what does a robot do? Well, generally, it is able to move, or like it's as moving parts. Not all robots can walk around, but it's able to move. Okay, might be maybe just rotating from one place to another, but it can move up and down. Yeah. And it is programmable. Okay, so it's able to move around. It's got moving parts. It's programmable. Okay, we can program it to do certain tasks. If you've got something like a Lego Mindstorm, it can still be considered to be a robot. Yeah, and we can move it around. It is mechanical. Okay, it's a machine. Okay. The robot plants seeds and stops when it reaches a fence. It then turns and continues planting seeds. The robot uses sensors and a microprocessor to know when it reaches the fence. Explain how the robot uses sensors and a microprocessor to know when it's reached the fence. So, okay, so it's going to be using some kind of distance or what they call a proximity sensor. Okay, so we've got the, I'm assuming the robot is on some kind of a robot plant seed. So let's say this is our robot on the front. It's like a tractor robot. Okay, and on there it's got some kind of a sensor. Okay, and there's our seeds. It's throwing seeds out the back. Yeah. So sensor, and there is the fence. Okay, so it's measuring the distance. I'm going to put that prox in ET. Okay, proximity. So it then turns and continues planting seeds. The robot uses sensors and a microprocessor to know when it reaches the fence. So we've got, first of all, sensor. Proximity sensor, which is connected to a ADC. Yeah, which is an analog to digital converter. That then goes to the micro processor. Okay, this is continuous. Okay, so the sensor is constantly sending a signal through the ADC to the microprocessor. Okay, continuous cycle, checking data stored in processor. Okay, i.e. this distance. Yeah. If there is a change, yeah, e.g. distance, signal is sent back to robot to change direction. Okay, usually a motor / actuator. Okay, spell that wrong. Double one C. An actuator. So it's used to rotate. Okay, so continuous signal, proximity sensor, measuring the distance, yeah, to the fence. Proximity sensor continuously sends data via an ADC to the microprocessor. This is checked against stored data in the processor. If there's a change in terms of e.g. the distance, then a signal is sent back to the robot to change the direction of the robot. We might also, I'm not going to write it down, we might also include a sensor in terms of here, when the seed, if we run out of seeds, then the machine would, then the robot would send a message, maybe back to the depot. If this is all automated, it might send a message back to the depot to say, I've stopped, I've got no more seeds to plant, so I'm going to stop here until somebody comes and fills me back up with seeds so I can continue up and down the field. So maybe another sensor in there, just some kind of a leveling sensor or a pressure pad maybe with seeds on it, and then as soon as there's no pressure on the pressure pad, then the robot stops. Possibly. Okay, 6 marks for that one. Let's go over here. Okay, it's a long question, this one. Give 2 advantages of farming using an automated robot to plant seeds. It should be more accurate. Okay. Distance between seeds. Okay. Obviously, the robot doesn't get tired. As long as it's got battery powered or whatever, petrol. Yeah. However the thing's powered, it can work. Doesn't get tired. Can work 24 hours a day. Okay? You're fine, I'll stop now. Okay? We'll come back to that. So when you come across a question like this, 2 disadvantages. Think about money. It's always money. So I would put something like expensive to purchase. Start up cost initial. Okay, expensive to purchase, startup cost, the initial start cost is expensive. Throw some keywords in, but also expensive to maintain. Okay, if robot breaks, high repair bill. Okay, I mean, you could mention it's de-skilling the farmers. You could mention that it might be taking jobs away from employees. Things like that. The unfairness, the ethics. But generally, if we talk about money, we're gonna get the marks. Okay. So moving on to F. How many robot questions are there? F. The robot is adapted to have machine learning capabilities, a little bit like generative AI. Okay. Explain how this improves the robot. We could talk about it learns about its environment, becomes more familiar with its surroundings. So any hazards, any problems, it will navigate, it will negotiate. But you could mention sort of avoid obstacles in the field. Okay, I think that only gets 2 marks. Okay, let's move on. Question 9. A company owner has installed a new network. Data, let me zoom in a bit. Yeah. A company owner has installed a new network. Data is correct before it is transmitted across the network. The company owner is concerned that data might have errors after transmission. Explain how data might have errors after transmission. Okay, we could talk about packet switching. I'm going to mention packet switching. Could lead to loss of data in wrong order, files become corrupted, possibly due to data collision. Okay, if the data is separated, then it hits other data, and then we might end up losing parts of it. So yeah, packet switching, loss of data, data reassembled in wrong order, file becomes corrupted due to data collisions. Okay, hello there. 2 minutes. Okay. The company owner decides to introduce an error detection system to check the data for errors after transmission. The error detection system uses an odd parity check, okay, and a positive automatic repeat, yeah, query, an ARQ. Okay, describe how the error detection system operates to check for errors. Okay, well, this sort of system, this odd parity check, you may have seen some questions on other past papers where they might have a grid. And the first column is set to parity. Okay, this is my parity bit in this column here. And then we've got 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. So I've got 4 sort of packets of data. Okay. Now, because it's set to odd parity, if I put some numbers in here, okay, let's change the colour of the pen. My parity bit, yeah, it's saying it's checking for odd parity. So if we look down here, we've got 1, 1, 1. So we've got 3 ones in this first row. So that would be 0 to keep 1, 2, 3 as being odd. Whereas here, 1, 2, 3, 4, 5, 6, yeah, that would be even. So I'm going to put a 1 in there to make it odd. Okay, here we've got an odd number, so that's fine. And here we've got an even number. So again, I'm going to put a 1 in there. So to make sure that the packets of data, these things here are my packets. Yeah, to make sure this packet of data is odd, yeah, it already is odd, so I'm just going to put a 0 in there, or a 1 to make an even packet odd. Okay, does that make sense? Okay, hopefully that makes sense. I'm going to put 1s added to packets of data to ensure each collection of binary 1s and 0s has an odd number of 1s. Okay, so that would be the first bit. Okay, I'll put here, yeah, the receiver, I have to see, except I have to see, don't worry about that. The receiver counts the 1s. Okay, if none of 1s does not match sender number of 1s, error in transmission. Okay, Okay, but that leads us on to the describe how the error detection system operates to check for errors in terms of ARQ. ARQ, the automatic repeat query. So let me just zoom out a little bit here, because it is for 8 marks, so I've got to go into a fair bit of detail. The way the ARQ works is if the check fails, so ARQ, okay, if the check fails, okay, then no message sent, okay, like a receipt, no message sent, like receipt, okay, my spelling is atrocious. If a receipt message is sent. Okay, so that's how ARQ works. So if no message is sent, this means a request to send again. Okay, it's a bit of a strange one. You think it was the other way around, but yeah. If no message is sent, i.e. no receipt, then there's a request that sort of signifies a request to send again. Okay? I think that would give us 8 marks. Maybe. Okay, let's do that. And finally, let's go into here. Final page. Give 2 other error detection methods that could be used. Let's zoom right in on this. Okay, give 2 other error detection methods that could be used. We've got checksum, okay, which basically checks, it's a little bit like what we just seen, the ARQ, but it's basically a sum of ones, or a calculation is sent with the packets, and the calculation is based on the packets that have been sent, and it checks a sum based on those packets. You may have seen modulo, where they're looking at the remainder value in some other questions. So checksum, and then another one might be a CRC, which if I remember rightly stands for cyclic redundancy check. Okay, and again that's to do with the remainder value. Okay, so CRC and checksum for 2 marks. That is what I would put down. I don't know the maps are more on the mark scheme. Okay, here we go. The company owner, for 5 marks, the company owner also installs a firewall. Okay, a firewall to help protect the network from hackers and malware. Oh my word. Explain how a firewall operates to help protect the network. Well, 1 can act as a filter. 2, I'll put control, incoming traffic. 2, set which, I'm just going to put for this website, which web pages not allowed. But it's not just about web pages. Okay, it's not just about web pages. It's about maybe things coming in through emails. Yeah, downloading software. If you were to download any software from the internet, so blocks potential malicious programs. Okay, 2, 3, 4, IDPS, intruder detector. So they can sort of filter, they can guess if there's any kind of robots or bots trying to access your information. And then 5, I mean, there's a few. I'm trying to think of the ones that you might be more familiar with. Blocks or doesn't allow file sharing. Like things like the Pirate Bay and piracy sites, file sharing sites. Okay? And then finally, again, quite a few of these, give 2 examples of malware that a firewall can help protect the network from. I'm going to put Trojan horse, okay, as being one, and I'm also going to put, I think I'm going to put ransomware. Okay, that's a couple of examples of malware. And I think that is your exam paper broken down into small parts. Okay, cover page 1, 2, 3, 4, 5, 6, 7, 8, 9 pages. Okay, so that is it for this paper. This is just a recap. Oh, yeah, this is computer science, paper 1, computer science, May, June 2024. Yeah, and it's an O-level paper, so it's 2210 is your syllabus, and it's the Zone 1, Edition 1. And remember, an hour and 45 minutes. Please remember, calculators are not allowed on this paper. Okay, thank you very much indeed, and I will see you next time. Bye for now. Thank you. Please continue to ask questions, leave your comments, hit notifications, and please subscribe. And finally, if you wish to buy me a coffee, I'd be truly grateful. Please visit buymeacoffee.com/learning zone. Thank you very much indeed. See you next time. Bye for now.